Texas Tech has quite an arsenal of observations available to try to solve some of the scientific hypotheses regarding tornado formation and sustenance. One being StickNet, which is what we call an in situ sampler. And basically, it's a tripod, much like a camera tripod. And on top of this tripod, we put a whole bunch of meteorological instrumentation. And we actually have separate pieces of instrumentation devoted to sampling temperature, for instance, the thermometer with the radiation shield, or wind. We have anemometry up there, which helps us out with that. So it basically looks like it's an engineering tripod. It's very rugged, and it can withstand, we think, when it's staked down, about 140 mile-per-hour winds in the absence of any impact from debris. And so with this, we basically put these observational assets in the path of these storms. We get out of the way, let the storm move over top of these probes, and we have 24 of them, so we can lay out a pretty broad, pretty broad array covering maybe 20 or 30 miles, and that allows us to just make measurements of how temperature and pressure and humidity vary over a broad region near the updraft of the parent thunderstorm for the tornado. The mobile radars work quite a bit different from StickNet. Mobile radars allow us to transmit electromagnetic energy out into the atmosphere, which is scattered back to the radar from the thunderstorm itself, including the tornado. And we basically exploit the Doppler shift, no different than the police officer who's using a radar gun to enforce the speed limit. It's the same principle, except instead of speeding vehicles, we're looking at hydrometeors in the atmosphere, bits of rain and hail, and we can tell what speed those are moving towards or away from us, and then we can actually discover what the three-dimensional state of the wind is around these tornadoes. And we're very excited about it. I mean, this has been the strength of Texas Tech for a long time, has been observational severe storm research. And we're at the point now where we've gained a lot of momentum and we've gained a lot of observational facilities, and we're just trying to make the strongest scientific contribution we can with these instruments.